So Valentine's Day is just around the corner. Have you got something for your girlfriend?
Oh I forgot!
Don't worry, I've got the perfect gift idea for you. Let me tell you about how our team made a solar-powered boost converter, and how you can too. A boost converter is a ChatGPT approved perfect gift, but when it came to actually building one, ChatGPT wasn't much help. Our objectives for this project were to build a boost converter for a solar-powered charger, optimize the boost converter's efficiency, and record and upload data to the cloud with the LabVIEW VI. First, we used data fitting methods in Excel to characterize the solar panel. Using our extracted solar panel parameters, we then simulated the module and the boost in LTspice. Since our components were already decided, we would then test different frequencies to aim for the highest output power we possibly can. After some optimizations, we obtained a power output of about 0.7 watts and a maximum efficiency of almost 81%. Using Arduino IDE, we programmed our Arduino to operate at a frequency of 31.2 kHz, which was large enough to ensure our inductor was in continuous conduction mode. Our boost converter is made with an inductor, a MOSFET and a diode. We also added a capacitor to filter our output and a current sensor which will be used later for data logging. For our first PCB, our good luck charm unfortunately did not work, and a bad trace design meant that it had an unintentional short circuit in it. So we had to redesign and reorder our PCB, a major setback which cost us about a week in how much time we had available for testing. But finally, after getting our redesigned PCB and soldering all our components, we now just needed a way to control it.
This is the LabVIEW, which we use to control the input settings as well as measure, calculate and upload key metrics from the circuit to the cloud. It can measure the input and output voltages, currents and power. It can also measure the temperature of the panel as well as the insulation using these equations. The LabVIEW also includes a PID, which can automatically adjust the duty cycle in order to meet specified target power outputs. Finally, the LabVIEW can upload all this data periodically to the cloud, as well as save it locally on a text file. During preliminary testing, we found our panel would get quite hot, which can significantly reduce the efficiency of the module, and so our project also featured a passive cooling system. We designed a heatsink using aluminium foil and a Coke can, which was designed to spread out the heat evenly and promote convective heat transfer away from the module. During testing, the module was also angled to face the sun directly, which also allowed for better airflow behind the module.
Before the final test day, we ran through everything. All systems were at 100%. So going into the real test, we were very confident. We were certain nothing could possibly go wrong. And then everything started going wrong. Giuseppe launched the wrong version of the LabVIEW and spent the first half scrambling. So no data uploaded for the first half. And our PID control decided to take a vacation. So none of the targeted power were hit that day, and my adapter decided to retire early, so I couldn't record anything for the team record part either. And Adam's LabVIEW were running fine, except his solar panel was only outputting a 200 milliwatts output power. And that concludes our day of the final test.
So looking back at this project, I think the big thing we got was very hands-on experience. We actually get some experience on how to use the software and the hardware. We actually learn how to use LTspice to model solar panels and the EDA to design PCB, and we also got to play around with LabVIEW. Of course, not everything went alright. Our board has some problem. We didn't do well with our PID control, but all those problems actually taught us to maybe double check everything and work better as a team. In the end, it was really a rewarding project and a good experience.
Oh my god, thank you so much. I'm gonna go make that right now. Hey baby, happy Valentine's Day. This is for you.
Oh, what? A boost converter! That's so sweet! This is my favorite! I love you, darling.